So this is my conversation piece, the implemented Java-based number-based converter. Um, so here we can see just the initializing the declaration of my variables. Um, and then we have this loop where all the actual processing of the code takes place. Um, and so pretty much the process is the same as shown in the flow chart. It asks for all the information that we need from the user, what number they want to convert, what base they're giving you, and then this just converts it to base 10 right away because we're going to need that later. And then also we ask what base it's in. And then since we have it in base 10, we check if they do want it in base 10, then we'll just output that right now, and then it'll just skip over all this other code that we have for the other bases. But in the event that they don't want base 10, we're going to convert this base 10 into binary, since all the other bases that we're looking at easily convert into decimal. I just do that first and then into binary, since it works a lot. The math works out a little easier in my head, so it goes into binary here. And then down here, since we have it in binary, we ask, or we don't ask since we already know what they want the output to be. If that output they want it is in base 2, then we'll output that right here. Um, and actually from when it gets converted into binary, it uses the same like shortcut method we used, where you divide by 2 to see what the remainder is and line them all up. And when I string that together, it was actually backwards, which is useful later because I'll talk about that in a second. But for here, that's just why we flip it here. I have a function at the bottom of the code that flips strings, so or inverts them. But it's useful to have the string backwards, because then we can easily add on extra digits to the front end where they don't matter, and then flip it. So here we can add on, because you want, when converting to octal, I found that was easier to have a number of digits that's so for octal, like divisible by 3, because then I could look at chunks of 3, convert those from binary into octal, which is kind of what we did when we were doing it by hand. You'd look at the chunks, and the code doesn't like looking at blank spaces at the beginning, so I just fill them with the zeros here before actually inverting it to the actual binary conversion. And then we can go by each group of 3, see what the octal value would be. If there's a 1 in the first position, they would add 4, then 2, then 1. And then that's added to the out string, which would be an octal now. And then once it's all strung together from this loop here, it'll output right here. And then 16 does the same thing, except now the binary string is we want it to be in groups of 4. So this will just repeat until there's 4 bits in every group. And then we'll invert it. And then we'll do the same thing we were doing for octals, loop for each group, see what the hexadecimal value is, and then assign that to the digit. And then the difference between here and here is octal only uses digits 0 through 8, so you can just use an integer variable to assign the value to the string that'll be outputted or output. But for hexadecimal, we actually need digits that go from 10, 11, 12, 13, 14, and 15. And so we can still use the same method of assigning the value to an integer, which is this digit variable right here. But then when we actually add it to the string for the hexadecimal, we go through this switch right here, in which if the digit is 10, then it assigns the character A, 11 assigns B all the way down to F. And the default case is that it'll just assign the digit, which would happen if it's 0 through 8. And then it'll print out the hexadecimal right here. And then this is just a bar. I'll show you in the when I run it, but this will just separate between the different entries. And then we have our function right here, which is just to flip the strings. So we can run it. Then over here in this window, we can see it asks what the number we want to convert is. So let's say we want to convert 7 from decimal. So we'll put 7 base 10. And then we want it in, let's say, binary, which is base 2. And it converts it, which is equal to 111 in base 2, which 7's low number. We know that's just 111. And then we could also double check that. We could enter 111 as base 2, then convert it into decimal, which it shows is 7 base 10. Then it asks us again. We could input, let's do a hexadecimal. Let's convert, we do 15 into hexadecimal. And so we want it in base 16, which is F base 16. Yeah, F base 16. So we can run through any of the conversions it'll be able to complete, and it's using the same methods that we learned in class, just implemented into a Java code to do that. I think that's it. We do one more, we get to show octal as well. So octal, let's do 8 base 8, or let's do base 10. Then we want it in octal, which is base 8. So 8 base 10 would be 10 base 8, which is correct because octal counts up to 7, and then the 8 would equal 1, 0. So that's it. Thanks for watching. Bye.